Today we start the vector calculus. Be silent. Vector calculus. In vector calculus, what is calculus? We have already done the calculus in class 12. Differentiation, integration, these are all the calculus. So here we will find out, or we will study the differentiation and integration of vector. Okay, of vector quantity. Now, to start the vector calculus, first we have to find out directional derivative. We have to know the directional derivative. Directional derivative. Directional derivative. If f x y z, if function of f x y z is defined and differentiable at each point x y z, defined and differentiable at each point x y z in a certain region of space, in a certain region of space, then the partial derivative of f x y z, function of x y z, then the partial derivative of f x y z in the direction of coordinate axis, ox, oy and oz, oy, oz of coordinate axis ox, oy and oz, that is del x, del y and del f, del z, del x, del y and del f, del z, directional derivatives are called as directional derivatives of x, of f, directional derivative of f along OX, OY and OZ are called directional derivatives of f along OX, OY and OZ, okay, respectively. Okay. So you know the derivative. Hello, what is partial derivative? We know that f is the function of x, y, z. Okay. So if we want to take the derivation of f with respect to x only, then that is called the partial derivative of f with respect to x. Okay. And we have the full derivative, the total derivative as df dx. Okay. And the partial derivative as del f del x. That means when we take the differentiation of x with respect to differentiation of f with respect to x, then all the functions y, z remain constant. Okay. When we take the differentiation of f along with respect to x only, then y and z remain constant. Okay. That is called the partial derivative. That is, we get the derivation partially. Okay. That is the partial differentiation. Partial differentiation. Okay. Now, directional derivative. Why it is called directional derivative? Because we take the derivation in a particular direction. So it is called directional derivative. Okay. Del x is the directional derivative along OX axis. Okay. This is the directional derivative. Now, what is vector differential operator? What is an operator? Vector differential operator. What is an operator? Don't talk. What is an operator? Anyone? Operator is which can operate on a function and give a new function or the same function. That is called the operator. Okay, a mathematical characteristic which can operate on some function and we get the same function or the new function. That is called the operator. Come on, देखो. ddx is an operator. Why? When ddx is operating on x square, we get 2x. So when ddx is operating on x square, we get the 2x. So this function and this function is same or not? X square and x are same function? No. Okay. X square is the function of x square and x is the function of x only. So we get a new function. But when ddx is operating on e to the power mx, then we get m e to the power mx. So this is the function, this is the function. So we get the same function with a constant. So ddx is an operator. Which can operate on something. And you must remember the operator is always in the left side of the function. Okay, dx or the operator is always left side of the function. There is no meaning of this one. E to the power mx dx. There is no meaning. You cannot operate in this way. Okay, function is always in the right side of the operator. Okay? This is the operator. Now, what is vector differential operator? Hey. Okay, vector differential operator. The vector differential operator. The vector differential operator del, del. The vector differential operator del vector. Okay? So del is the vector differential operator. Okay? So by this vector, there is the I cap, j cap, and k cap, and del del x, del del y, del del j. Okay, so why this is called the vector differential operator, and it is denoted by del. And you can see that del is like this, not like this. Okay, it is not the operator. What happened? This is del only. ये मतलब vector होगा ना. Del x समझ लीजिए. Del x, this one, and vector operator is this one. Okay, del operator over x. So this is called the vector differential operator. So in calculus, as I told you, it is the differentiation. So in vector calculus, we use the del operator. Okay, vector differential operator del. Now gradient of a scalar function. Gradient of a scalar function. Gradient of a scalar function. So what do we mean by gradient? Gradient. What is gradient? What is the relation between electric field and potential? E equals to dvdx. dvdx. That means gradient is if any scalar quantity change with respect to distance. That is called the gradient. What is it? Gradient. If anything change with respect to distance, then that is called the gradient. And we have to take the gradient of a scalar function, not a vector function. देखो देखो gradient. আগে তোমাদের রেজিস্ট্রেশনটা হোক, রেজিস্ট্রেশন নাম করে মাস্ট রেজিস্ট্রেশন হবে ইউনিভার্সিটি এক্সাম রোল নাম্বার আসবে নম্বরটা তো লাস্টে দিতে হবে প্রথমটা না না এই ফাইনাল বলছো সিএটা হ্যাঁ সিএটা নভেম্বরে আছে লাস্টে হ্যাঁ যতদূর পড়ানো হবে কেন সিলেবাস যেগুলো হচ্ছে সেটা দেখুন the gradient is the rate of change of a quantity. The gradient is the rate of change of a quantity with respect to distance. The gradient is the rate of change of a quantity with respect to distance. In the next para, when vector differential operator del operates on a scalar function, when a vector differential operator del operates on a scalar function phi x y z, function of x y z, the obtained vector is called gradient del phi. This is called the gradient. Now here we don't put any dot or cross. Why? Because phi is a scalar quantity. Dot product is between the two vectors. Cross product is also between the two vectors. If one vector and one scalar, then we don't put a dot or cross. It is only the operator. Operation is there. Okay, grad phi. This is called grad phi or gradient of phi. Okay, gradient of phi of a scalar. Gradient of phi of a scalar. Therefore, grad phi equals to I cap del del x plus j cap del del y plus k cap del del j operating on phi function of x, y, z. Okay? Because there is I cap del del x plus j cap del del y plus k cap del del z, and it's operate on phi x, y, z. Phi is a scalar quantity. Then what we will get? So this is equals to gradient of phi equals to I cap del phi del x plus del phi del y j cap del phi del y plus k cap del phi del z. This is the gradient of a scalar quantity. Gradient of a scalar quantity. So you can see that the gradient of a scalar is a vector quantity. Because on the right side there is I cap, j cap, k cap. So if you take the gradient of a scalar quantity, that will be a vector quantity. So okay, so gradient of phi is a vector quantity. Why? Because there is a I cap, j cap, k cap in the right side. So gradient of phi is a vector quantity. Gradient of phi is a vector quantity. Okay. So if it is a vector quantity, then what is the direction? It must have the direction. So what is the direction? First follow. What are the scalar quantity? Give some example of scalar quantity. Time. Wait. Not much mass. So here the direction. Temperature. Okay. Temperature, time, distance. These are the scalar quantity. Now, so what is the direction of the gradient? If this is a metallic rod, okay. Now, if we hit this portion, then what's happened? If we hit this portion, then what's happened? It transferred along this direction. Why? Because there the temperature is high, here the temperature is low. Why it flows? It flows due to the temperature difference. From higher to lower direction. Now, that is the gradient of temperature, gradient of T. That means change in temperature with respect to distance. Okay, and what is the direction? The direction of the gradient of temperature is along the normal where the temperature is constant. Temperature is constant means if we take the cross section of this one, then in this cross section temperature is constant at a time. Okay, then what's happened? Then the gradient of temperature is along the direction which is perpendicular to the surface where the temperature is constant. So the temperature flows in this direction, normal direction, where the temperature is constant. That is the common direction of gradient of phi. It is the directional derivative. It is the directional derivative of a scalar function. It is the directional derivative of a scalar function along the normal to the surface, along the normal to the surface on which it remains constant, along the normal to the surface on which it remains constant. বোঝা গেল? হ্যাঁ, যেখানে কনস্ট্যান্ট তার পারপেন্ডিকুলার ডিরেকশনে ফ্লো করবে। And it is also a directional derivative. Why? Because temperature change with respect to distance. We know that if anything change with respect to distance, then that is called the directional derivative or the gradient. So in a certain direction, the temperature changes. So why it is called directional derivative of temperature. Now, hello. So if we get the gradient of phi, now this is the surface. This is the surface. Then the gradient of temperature is along this direction. This is the gradient of T. Temperature. Now, if we want to take the gradient along this direction, along a direction where the unit vector is A. Okay, that means this is the surface in this direction. This is the gradient of temperature. Now, if you want to take in any direction, what is the change of temperature with respect to distance? Then what to do? Then you have to take the dot product of gradient of T and the unit vector along this direction. Dot product of grad of T dot the unit vector along this direction. That is dot A. That is grad T dot A. Okay, that is the change of temperature in any direction. That is in any direction where the unit vector is A. If you want to take the gradient of temperature along this direction, it is the normal on the surface. So that this is the grad T. Now, if you want to take the component of grad T along this direction, in an arbitrary direction, not perpendicular to the surface. Then we have to take the unit vector along this direction. Along this direction, we have to find out the unit vector. Then we have to take the dot product of grad T and A cap. Unit vector of A. That is the change of temperature along the direction of A. So this is gradient of T dot A cap. Along the direction of the temperature. Okay. The component of grad phi, phi is any scalar quantity. Grad phi in the direction of a unit vector A cap. In the direction of a unit vector A cap, small a cap. In the direction of a unit vector A cap is given by grad phi dot A cap. So where here we have to put a dot. Why? Because this is a vector, this is also a vector. Okay, grad phi dot A. That means how to operator? Grad phi dot A means grad phi a magnitude. A is the unit vector 1 into cos theta. Grad phi component along A cap. Cos theta key. If you want to take the component of anything along any direction, along a angle theta, that is cos theta, grad phi cos theta. Grad phi cos theta. Why? The magnitude of A cap is 1. Okay. Full stop. It is called directional derivative of phi. It is called directional derivative of phi in the direction A cap. In the direction A cap. Full stop. Physically, this is the rate of change of phi physically this is the rate of change of phi at xyz, rate of change of phi at xyz, this point along the direction a cap, rate of change of phi at xyz along a cap. Okay, grad phi is the rate of change of phi at xyz normal to the surface. Okay, and grad phi dot a is physically it is defined as rate of change of phi at xyz along a cap. Okay, full stop. So this is the gradient of phi. Now, do a numerical problem. Solve a numerical problem. Look, problem 1. Calculate the unit vector. Calculate the unit vector which is normal to the surface. Calculate the unit vector which is normal to the surface phi equals to which is normal to the surface phi equals to x square y plus x y square plus 3xyz at the point 1 1 minus 1. You will calculate the unit vector which is normal to the surface phi. Surface is a, therefore phi is the scalar quantity, which is normal to the surface phi at the point 1 1 minus 1. Here we go to normal. That means you have to find out the grad of phi, because grad phi is normal to the surface phi. Then we go. Here grad phi equals to I cap del x plus j caps del y plus k cap del z. Okay? Phi means x square y plus x y square plus 3xy z. Okay, I cap del x plus j cap del y plus k cap del z. So this is equals to क्या मैं बोल रहा हूँ del x of phi পুরোটা হবে কিন্তু it is not a dot তাই কি হবে del x of this one কত হবে তাহলে I cap del x 2xy plus y square plus 3yz. Del x করছি is the partial derivation. If it is partial derivation, then with respect to x, y is constant, yz is constant. That is called the partial differentiation. Okay, only you have to take the differentiation with respect to x. Okay, plus j cap del y. J cap del y. Del y means x squared plus 2xy plus 3 k cap, then there is z. So this is 0, this is 0. Because xy are constant. Here it is only 3yz. 3yxy. 3xy. Now we have to find out at the point 1, 1 minus 1. Okay, so this is the normal which is normal to the surface phi. Now we have to find out at x, y, z. Normal at x, y, z. Then what to do? Therefore, grad phi at 1, 1 minus 1 equals to এটা কত হচ্ছে 2 I cap 2 plus 1 2 plus 1 এটা কত মাইনাস তাই তো তাহলে মাইনাস 2 plus 1 minus 3 plus j cap এটা হলো 1 plus 2 minus 3 plus j cap k cap only 3 by x are 1 1 1 3 k cap. So this is equals to 3 k cap. So grad phi at 1 1 minus 1 is 3 k cap. Now we have to find out the unit vector normal to the surface. Therefore, the unit vector normal to the surface phi. Therefore, the unit vector normal to the surface phi is n cap equals to 3 a cap by root over 3 square. Unit vector. So this is equals to a cap. This is the unit vectors normal to the surface phi at the point 1 1 minus 1. Okay, so this is the gradient. So if you want to find out the normal of a surface, that is normal of a scalar quantity, then you have to find out the gradient of that scalar quantity. Okay, so we have to do this one. In the next class we start divergence.